It's Alpha Gamers, Alpha Gamer Mindset here, trying to get you guys, gamer build you guys into getting better, whatever you're doing. Any kind of skill development, you can get better at, you can improve at. And that's what I'm doing right now. Just to pick up off where we left off with the last video, just talking about my finals. I just took my third final a few hours ago, actually. It was for math 317, which is Intro to Real Analysis Part 2. So if you don't know what that is, it's basically just integrals, it's continuity, it's some sequences, function stuff. But I actually really like the class. That was a lot of fun. I'm grading it next term, which is cool. Because I get to do more of this stuff again. I think it's good for remembering it. But the final went really well. Actually, I was surprised. I didn't really study. I kind of just made a note sheet, went over all the theorems in the book, and then I really didn't study at all. I should have in hindsight. One of the questions that I was not prepared for, and it was just a mistake. It's just a really big. I overlooked that one pretty severely. But it don't really matter too much because we'll go over the questions. So there are 5 questions. The first one was about something the teacher made up. It was a pseudo definition of continuity, but he called it 1 continuity, where basically epsilon and delta are also less than 1, which doesn't change anything. So, and it was like, say, is it the same or is it it's basically a true-false question, and then if it's true, prove it. So, I actually opened the test up and I looked at this and I was panicking. I was panicking the whole test. I was like, shoot, what do I do? I'm doomed. We have 2 hours to do the test, but I was just very uh-oh. I was like, I don't know what I'm doing. I don't know how to answer this. I don't know how to prove this. So I was pretty panicky. And then after about 5 or 10 minutes go by, I have nothing written down and I'm just like, this sucks. And it's getting worse. So I skipped that one. And then, but I guess I'll go over my thoughts on it. But, it's actually a really easy question. Basically, you just write out the definition of continuity, and then, but you choose delta to be the minimum of 1. And, I guess what you do is you assume the function's continuous. So you write out the definition of delta, or you write out the definition of, continuity. You have a delta so that, I guess. See, in hindsight, I think the way I saw it was kind of wrong, but I guess it's the right solution. But it's I wrote it wrong. Basically, what you should do is write out the definition of continuity, and then you can choose. You choose delta to be the minimum of 1, and beta, whichever one's smaller, because beta was supposed to be less than 1, and delta is just greater than 0. Doesn't matter. So then you just choose delta to be the minimum of either 1 or beta, and then since it's continuous, then when x minus c is less than that, you should still have it that it's less than epsilon. So then we know beta is less than delta, or it's less than or equal to delta, and so if it's continuous, it should be 1 continuous. And then you can do the opposite, where you write out the definition of 1 continuous, which for his question, all that means is it's beta, which is normally supposed to be delta, is between 1 and 0. Normally delta can be just anything greater than 0, but in this context it has to be less than 1 and greater than 0. But it doesn't matter, because if beta is less than 0, or if beta is less than 1, well, delta is still less than 1. So if it's beta continuous, it's obviously delta continuous. If it's delta continuous, well, you can set delta to be the minimum of 1 and beta. So if it's delta continuous, beta would be. It's still beta continuous, right? There's delta in that regard. It's still less than or equal to 1. So it's either way it's continuous. So I think the way I wrote that, it was a little bit funny. I don't know if he'll grade that differently. I think my proof is pretty well written outside of that, and conceptually it makes tons of sense. So I think I'll get at least most marks on that one. Second question was. I forget actually. Oh yeah, it was a mean value theorem question, which is so in the midterm there are 2 mean value theorem questions, and I totally I got destroyed in them. I basically didn't answer anything, which is the whole reason I started changing how I approaching proofs, and it's kind of the inspiration of my whole term, all these videos. Yeah, I just basically let them blank. I didn't know what I was doing. And then so these questions, I did the exact formula that I've been talking about in all the last 2 videos and all week. Is like it was an if and only if proof. So we need to prove both sides. So the backwards direction I proved first because I thought it was easier. You just use the definition of differentiable, and this is you can tell based on the question. So I think it was if f prime of x is equal to 0 for f is from R to R. If f prime of x is equal to 0 for all x and a, then prove that for all c for all x and r, then f of c for some c is or no, my bad, f of x is equal to c for some c and r, right? So if f prime of x is equal to 0, then prove that every f of x is equal to some number, and then if every f of x is equal to some number, then the derivative is equal to 0. Basically, it's a constant function, and you're just trying to prove that if the derivative of a constant function, or if the derivative is always 0, it's always constant, and if it's always constant, it's always 0, which is a really cool question, I think, for test. I don't know, it might be too easy. I thought it was too easy, because the backwards direction, where you know that it's constant, just derive it. Find the derivative, and then what you get is that you have a derivative times b minus a is equal to c minus c. And actually, that's not even true. You have the derivative is equal to f of x minus f of c over something, are the limit of this. But you have f of x is equal to c. So then you have 0 minus 0, and f of c is equal to c, because every f of x is equal to c. So then you have an f of c is a point, likewise as f of x. So then you have 0 over some number, limit of that. So you have limit of 0, which is 0. So you just have 0. So you have f prime of x is equal to 0. Well, you have f prime of c is equal to 0, right? But then for any c and a, or any c and r, which means every c and r, which means f of x. So you have alternatively, I guess what you should do is just take the limit, or just take the derivative of f of x, right? I did have f of c, but it doesn't really matter. It's and he might take marks off for that. I'm not sure, because I'm not 100% sure what proof is more sensible there. I think taking the derivative of f of x is better, but I'm not super good at that kind of technical stuff. But yeah, it doesn't really matter. It's kind of conceptually it's easy. The forward direction, it's really similar. You have to do mean value theorem. But yeah, I thought this question was cool because if you write out the hypothesis for the backwards direction, all you have is that f of x equals c. That's all you have, and it's obviously not a mean value theorem proof because you don't know what the derivative is. So how do you even use mean value theorem? But the backwards direction, you do know that f of x equals c, right? So using the definition of derivative, I think, is more reasonable, because then you can derive f of c. You know that it's continuous, and you know it's differentiable, because he also says it's differentiable, so you can do that. Plus, I think it's cool because it uses in the hypothesis that it's differentiable. What was the one thing I said? Like, in a math proof, you have to use every point of the hypothesis. If you don't use every point of the hypothesis, you're doing it wrong, right? So it's like, into this proof, I go in, I wrote down the hypothesis and the conclusion of both directions, and then tried to do one thing, and then it didn't work, do another thing, didn't work, go back. Well, I tried to do one thing, it worked. Tried to do another thing. I didn't do the other thing. I just got lucky when I tried the first time with both things. But point is, you try something, if it doesn't work, just scrap it and move on to the next thing. Just be quick about it, right? That way we can do these proofs quickly. And they're easy proofs, so yeah, like they should work. And yeah, it worked. Other direction is really easy too. Just use the mean value theorem. You know that f prime of x equals 0, so f prime of c equals f of b minus f of a over f b minus a. Well, f prime of c is 0, so you have basically b minus f of b equals f of a, because that's how you simplify it. Which means that any point, because you have a r is. See, this is where again I may have gotten marked off. I just said that b and a are arbitrary points on R. So for any arbitrary points in R, you get that f of b equals f of a, which means every point in R equals each other, right? So every point is the same. So that's not really a clean argument. I think maybe I probably got marked points off there. Maybe you could use an induction argument to prove it's every point. Maybe there's another way to prove it's every point. I don't know, but effectively, logically, every point is equal to each other. And then that means that like f of a is equal to some point c, and f of b equals c. Or you could even say f of b, yeah, how about this? F of b f of x for all x and a equals, actually, yeah, f of x for all x and a equals f of b, which equals f of c, right? And you could say f of c equals some point, and so then f of x equals at some point c, which is what you're trying to prove. So that one, I think it went well conceptually, but yeah, I'd probably miss some points there. Anyway, the third question was about, it's a partition question, and it's a funny graph that we looked at a bunch of these in class. So this one, again, I thought it was like really obvious. You have a piecewise function h where x is 1 if h equals the 1 if x is equal to 1 over n for some n, right? And then it's 0 otherwise. So all this is like a line on a graph that goes down, and then as it gets closer to 1, there's more points. Because, like, actually, no, it's the opposite way. At 1 there's 1 point, at 1/2 there's 1 point, and then as it gets away from n, maybe it was a different function. So because the way I graphed it, if it got closer to 1, there's more points. As it gets away from the 1, there's more points. But it doesn't really matter, because point is that the you just partition it so that like 1 over 2n, which is smaller than 1 over n, so that every infimum of the partitions is 0. So then the lower bound is 0, and then you can find you can partition it in a specific way, such that the upper partition, or the upper integral, well, the upper partition of p, you can get it so that it equals 3 epsilon over 4, which is less than epsilon. You can do that if you partition it correctly, but I just forgot to do that in the homework. And I know when I did the homework, it took me forever. So I just, because this is a problem in class, I just took what he did in class and said, you basically have a finite, because you should have an infinite number of partitions, but you basically have, it's still integrable using, there's a theorem at 7.3.2. So you can still, he said this in class, and I kind of fudged the argument there. I said there's a finite number of points. There's not a finite number of points. There's another reason that you can do that, but you basically just do that for every point, and you know that this works because there's always a, anyway, you know it works because that proves it's integrable. I mean, if it's integrable, the lower and upper partitions are equal, which means they're equal to 0, because the lower partition is equal to 0. And since the lower and upper equal to 0, the integral is equal to 0. So problem solved. So I did that conceptually, did it right. But yeah, I think I fudged the argument a little bit. So I think I'll make some points there. But I actually did really well in that one. The fourth one was a computational one with a partition, which I thought was cool because the function was x squared, but it was from 0 to 1. And x squared from 0 to 1 is actually lower than x. And x squared from 1 to anything higher than anything up or higher is higher than x. So 1 over 2 squared is less than 1. Is less than 1 over 2, right? Which is cool because the supremum, or the greatest value between 1 over 2 and 1 over 4, or 1 over 2, 1 over 2 and 1 over 3 is 1 over 2. So I think I messed up when I was writing it. I think I messed it up, but I mean, conceptually I definitely did it right, where I must have, I had this problem. So I did this problem first. It took me like 45 minutes because I did it and then I realized I did it wrong, so I had to redo it. And then I think I got confused on the algebra. So I'm pretty sure I got the wrong answer, but it was the right vein. So I definitely am going to get full credit for that, but I did really well on it. And then the last problem was all true false, and I was underprepared for these, but I did so well in the first 4 problems. And one of them he gave us as a freebie because he wrote it wrong and he just felt it was unfair. So there was only 9. And I mean, I'm assuming I got half of them right and half wrong, right? I should have just said true for every problem. Be like, look, that's probably going to be, that way I don't get them all wrong. But I basically got half right and half wrong. And, I got the first 4 correct. I didn't get full credit on them, but I got the first 4 pretty well. And I got 12 points on the last question. I mean, it's only I have 100 points. I probably got somewhere between a 70 and a 90, which is really good. I got a 70% on the midterm last In 316, I got a 70% in the midterm, and that was one of the higher grades in the class. It was one of the highest grades in the class. The class is curved. I don't think this class is going to be curved because like the people I know were a lot better at the material, and our grades were a lot higher. The homework grades were a lot higher. So I think that I don't think the class is going to be curved. But yeah, I could have possibly got an A in the class, so I'm pretty happy about. At least got a B or a B plus. So yeah, I thought it went pretty well. But yeah, just the obvious thing, and I mean even explained to you guys in the video, you already know, like just a lot better at the proofs. I mean, I was able to. I didn't even study for the test. Like I was able to go into the test, look at the problem that I was unfamiliar with, and then prove it using the arguments I've been talking about. Like that's kind of the it was like it finally it all came together. 316 was a struggle. I mean, it's horrible, very difficult class. This term 347 and 317 were both very difficult. Linear algebra is kind of kicking my ass at the end, just the proofs, and then somehow at the end here it all came together. So I'm really happy about that. And I'm only taking 2 classes next term. It's gonna be a really easy term. So I'm actually gonna stream Link to the Past, I think, because I need a little bit of money. So I think I'm gonna stream Link to the Past daily, just for a few hours a day, just to try to make a few $100s a month, which should cover my bills. But yeah, I mean, can't say more. Honestly, it just worked out. The whole thing worked out really well.